Good morning, my dear students. My name is Nirdvayana. I am currently available at the Hamlet Tuition Center, Brahmatol, Kathmandu, and the Kumudini Kunju Secondary School, Kalimati, Kathmandu. My dear students of grade 9, this is your science class, and we have been studying about the lesson light. Okay, this is your 6th chapter from your book, and it belongs to physics, and it is the second last lesson from your physics. Okay, after this we have to study about current, electricity and magnetism, and that concludes our physics lesson for this year. Okay, in our previous class we discussed about refraction of light through a glass slab, yes, and we also discussed about the laws of refraction of light. Okay, today in today's class we will be discussing refractive index, yes, and the refractive index is actually the second point of laws of refraction. Okay, see the second point, what does it say? The ratio of sine of angle of incidence means sine I to the sine of angle of refraction, that means sine R. Well, the ratio of sine I and sine R for a given pair of medium is always constant. Okay, whenever we discuss about refraction, there is always involvement of two medium, you know that. Okay, because refraction occurs only when light enters from one medium to another medium. If there is no change in medium, then there won't be any refraction. Yes, an angle of incidence is formed in first medium, whereas angle of refraction is formed in second medium. Okay, now if we take sine value of these angles, then the ratio will always be constant for a given pair of medium, and that constant is known as refractive index or mu. And refractive index suggests you, it indicates you that to what extent is the light ray bent when passing through that medium. Refractive index gives you the extent to which the light ray is bent when passing through that medium. If the value of refractive index is 1, then there is no refraction. If the value of refractive index is 1, then there is no refraction. If the value is more than 1, then there will be downward bending, or the bending of light ray toward normal. Okay, if the value of refractive index is more than 1, the light will bend toward normal, and higher the value, more will be the bending. Are you getting me or not? Okay, let's see here. Suppose this is an object, yes, and this is an incident ray. Okay, this is an incident ray. Now, okay, this is an incident ray. Now, if the refractive index is 1, okay, if the refractive index is 1, what will happen? There will be no refraction. Okay, this is the case when refractive index is equals to 1. If refractive index is equals to 1, there is no refraction, the light simply goes straight. Okay, now I need to draw a normal point, normal here, and the normal should be dashed. Okay, now if the refractive index, the value of refractive index is greater than 1, like say 1.1, 1.2, 1.3 or 1.5, like that, if the value of refractive index is greater than 1, then the light ray will bend toward normal. Okay, and if the refractive index is just say 1.1, then it will bend just by a little bit. If its value increases, then it will bend even more, the bending increases. Okay, as the value for refractive index keep on increasing, the bending also keeps on increasing. More the value of refractive index, more the bending of light will be. Understood? More the value of refractive index, more the bending of light will be. Now another case is there. If the value of refractive index is less than 1 means it's not negative term, okay, it never gives us negative term. Less than 1 means like 0.9, 0.8, 0.5. Then in that case, okay, let me again draw this. Okay, in that case what happens, the light ray bends away from normal. Remember, if the Ri is more than 1, it bends toward normal. If it is less than 1, it bends away from normal. And higher the value of Ri, more will be the bending away from normal. Understood or not? Yes? Okay, that is the essence of refractive index. Okay, see the note. Refractive index is defined as the ratio of the sine of angle of incidence, that means sine I, to the sine of angle of refraction, that means sine R. So Ri equals to sine I by sine R. Okay, it is indicated by mu. This sine, it is actually a Greek letter, yes, and it is read as mu. Mu, it is combination of m and u. Okay, m and u, mu, and it refers to the extent of bending of light when light enters from one medium to another. We just discussed about this, yes. Okay, it is always constant for a given pair of medium. Okay, when light enters from say air to water, then whatever is the angle of incidence does not matter. According to angle of incidence, angle of refraction will also change, yes. Whatever is the angle of incidence does not matter, but refractive index will always remain same, that is 1.33. angle of incidence चाहे जति सुकै होस्, अब angle of incidence बढाएपछि angle of refraction पनि बढ्छ हैन। या angle of incidence घटायो भने angle of refraction पनि घट्छ, त्यही रेशियोमा घट्छ है। र के हुन्छ भने त्यो दुईवटा एंगलको साइन को रेशियो लियो भने चाहिँ सधैँ के हुन्छ, it is always 1.33, always. Okay, so it is constant for a given pair of medium. Now memorize this, understand this formula, and you need to memorize it. If you understand it, then it won't be a problem to memorize it. Okay, next, for a given pair of medium, ratio of velocity of light in two medium is numerically equal to the refractive index. Now you need to understand this point. What we discussed in our previous class is that the main cause of refraction of light is change in velocity of light. Yes, the main cause of refractive index, refraction of light is change in velocity in different in different medium. When light is traveling in air, then its velocity would be 3 into 10 to the power 8 meter per second. But when light enters into water, then its velocity would be 2.27 into 10 to the power 8 meter per second. See, when light travels from one medium to another medium, its velocity changes. Since the change in velocity is the cause of refraction, then the ratio of change in velocity also dictates the extent of bending. Okay, the ratio of change in velocity also dictates the extent of bending of light. Okay, if velocity changes by very small amount, then light will bend with very small extent as well. If velocity of light changes by large amount, if there is drastic change in velocity, then the light would bend even more. Light would bend sharply. Okay, that is why the ratio of velocity of light in two medium is numerically equivalent to refractive index. Numerically, I am saying numerically. Okay, the ratio of velocity of light in two medium is numerically equivalent to refractive index of these two medium. Yes, that is why we can also mathematically state that Ri is equal to velocity of light in medium 1 divided by velocity of light in medium 2. Yes. Okay. ratio, since these are the ratio of same quantities, yes, in this case it is the ratio of sine, yes, and in this case it is the ratio of velocity. Whichever formula you take, refractive index is the ratio of two similar physical quantities. Okay, so both numerator and denominator will have same SI unit, which will cancel on both sides. Okay, now let's come to next concept, the concept of real and apparent depth. Well, about this we discussed it on our first class regarding light chapter. Yes, in our first class of light chapter we discussed this. Actually it was the third or fourth example. Let me see the page number 1. Okay, see here we discussed about this, isn't it? This is a pond. Okay, this is a pond, and while you look below the pond, when you look down, what do you see? You can see the stones at bottom, yes, the rocks at bottom, and it seems like you can hand pick them. Okay, these rocks can be reached with your hand, it seems like that, but if you try to reach for it, you will never get it. Okay, if you even get down the water, then also you might drown completely, but the stone, the rock will still not be in your hand. Okay, the actual depth, well, actual depth is known as real depth, and the depth which appears to be, that is known as apparent depth. Okay, actual depth versus apparent depth. Okay, now let's get back to our current topic. Real depth refers to the actual depth of a pond. When looked down the pond, however, we do not see its actual depth. A pond always seems to be shallower. Shallower means less depth. कम गहिरो भएकोलाई हामी shallow भन्छ है. Okay, a pond always seems to be shallower than its actual depth due to refraction of light. It is called apparent depth. अब हेर त्यो किन हुन्छ त apparent depth? किन pond चाहिँ actual depth जति हो त्यति देखिदैन त भन्दाखेरि रिजन हेर त, तिमीले यो डायग्राम सहित नै एक्सप्लेन गर्नुपर्छ है यदि तिमीलाई क्वेशन आयो भने. A pond does not seem to be of its actual depth, or the pond seems to be shallower than its actual depth. Why? Very frequent question. Okay, let me assign that in your assignment before I forget it. I am very much forgetful, if you know that. Okay, if you know me, I'm very much forgetful. Okay, so a pond appears shallower than its actual depth. Why? Okay, this is an assignment question for you. I'm not going to do that. I'm only going to explain it, but you have to write on your own. I'm not going to write it down. Okay, now see, this is a pond. Okay, better to say this is water. Okay, and this is the bottom of pond. Okay, and a point, we consider a point on the bottom of pond which is considered as O. Okay, O is the point, any point on the bottom of pond. Okay, so from that particular point, millions of light rays are reflecting in all direction. Yes, millions of light rays are reflecting in all direction, but we only need to take 2 light rays. Yes, the first light ray, it happens to be, we are taking the light ray which is traveling straight in perpendicular direction. Okay, the light ray which is traveling perpendicular to the surface of water does not undergo refraction. It will move just straight. Yes, and the second light ray, see, the light ray which is bending. Yes, the light ray which is bending, it strikes the surface at this point Q. Okay, it strikes the surface at the point Q, and in this case you can see water is rarer or denser medium when compared to air? Well, water is denser medium, whereas air is rarer medium. Okay, so now you tell me what happens when light travels from denser medium to rarer medium. What happens? Will it bend toward normal or away from normal? Definitely it will bend away from normal. Yes, if there was no refraction, then okay, the light ray would have traveled like this. Yes, if there was no refraction, the light ray would actually travel like this. Okay, when your eye receives both of these light rays, they exactly meet here, O, and you exactly see the bottom of pond, exactly where it is. Okay, but since light ray is traveling from denser to rarer medium, the light ray bends. Okay, now it bends away from normal or toward normal? Well, it bends away from normal. That means this light ray would not travel the usual path, but it will travel this way. It is bent, isn't it? It is bent. Yes. Now, when your eyes receive both of these refracted light rays, then what happens? These two light rays are divergent light rays. Yes, divergent beam. They will never intersect, but your brain perceives them to be coming from a common source. And what is that common source? You need to imagine. You need to backtrace this light. Yes, your brain imagines this light ray to be coming from this point, I, not from this point. Okay, your brain cannot manipulate the bending of light. Your brain considers the light to travel in straight line only. Straight line only. Okay, that is why your brain perceives that this light ray is actually coming from this point, I. Okay, and it happens that the two refracted light rays, they actually meet at point I. Okay, so our brain creates an image of the bottom of pond at I. जुन कुरा यहाँ छ O मा छ, त्यो कुरा हाम्रो ब्रेनले कहाँ इमेज क्रिएट गर्छ त? हाम्रो ब्रेनले कहाँ देख्छ त? I मा देख्छ. सो एक्चुअली पन्डको बटम यहाँ छ, तर हामी कहाँ देख्छौं? यहाँ देख्छौं. हामी यो देख्दैनौं. It is there, but we do not see it there. It is there, but we do not see. However, it is not here, I, this partial depth. It is not there, but we see it. है, यहाँ मेरो ठ्याक्कै उल्टो भएछ र apparent depth यहाँ माथि हुनुपर्ने है यो. Okay, sorry for my mistake. I happen to make a lot of mistake, but I also make my corrections. Okay, when you make mistake but still you make your corrections, then that mistake is not a mistake. If you make mistake and still you know you have made a mistake and yet you are not ready to acknowledge your mistake, admit your mistake, or you are not ready to correct yourself, then that is a mistake. Okay, this is Nirvani. Okay, take it. Okay, you understand this? Okay, so apparent depth, now you got it. Yes. Okay, this is the apparent depth. The virtual depth means you will see the bottom of pond at this point, but the bottom of pond is not here. It is not here. Actually, the bottom of pond is here, but you will see it here. That is the gist of apparent depth. So the pond is actually this much depth. Yes, this much deep. That is real depth, but it appears to be only this much deep. That is apparent depth. And this is also because of refraction of light, isn't it? And this is also because of extent of bending. If the light ray bends even more, then the bottom of pond would rise even higher. Yes, if the light ray bends less, then the bottom of pond would rise lesser. Okay, that's why the ratio of real depth and apparent depth is also numerically equal to refractive index. Got it? So until now we have got three different relations, mathematical relations for refractive index. Yes, number one, Ri equals to sin I by sin R. Number two, Ri equals to velocity of light in medium 1 by medium 2, and number 3, Ri equals to real depth by apparent depth. Okay, so now by with the help of these three formulas, these three relations, these three will be your weapons. Now we are going to war. Okay. Okay, keep your weapon loaded. Okay, we are going to solve some numerical problems here. Okay, first question, see, calculate the refractive index of a glass medium if the angle of incidence and angle of refraction are 45 degree and 20 degree respectively. Okay, we need to write given information first. Angle of incidence, that means I, is equals to 45 degree. And then angle of refraction R is 28 degree. Yes, now we need to find refractive index of what? Of glass. With respect to what? With respect to WRT stands for with respect to. With respect to air, means light is traveling from air into glass. It does not say anything about first medium, means the first medium is always air. Okay, and this we write it like this: air, glass, bracket close, and here we need to give the sign of refractive index. Okay, and the first medium is written as subscript and second medium is written as superscript. Okay, okay, let's continue. So you do not need to write like this. Okay, you can simply write mu. I write like this only for your information. Okay, it is, we do not know how much is it. Okay, as we know, now which relation will you have to use if you are given I and R? Which relation will you have to use? Ri is equals to which one? Well, if I and R given, angle of incidence and angle of refraction are given, then you need to use this formula. Yes, let's use it here. Okay, or Ri is equals to, once again I need to paste it, because in second step what I need to do, I simply have to substitute the value of I and R. I is 45. Okay, space पुगेन, ठीक छ, केही छैन बाबु, म बढाइदिइहाल्छु ल, तिमीलाई कति चाहिन्छ त्यति. Okay, and R, the value of R is 28. Now what is the value of sine 45? Sine 45, what is the value of sine 45? Okay, I need to use calculator. Yes, okay, okay, calculator, advanced or scientific. Yes, now where is sine? Okay, trigonometry, sine कति चाहियो हामीलाई? 45 है. ए फेरि गरौँ है, मैले साइन ए यस्तो रहेछ ल, मैले बुझेन. 45 साइन यसरी चाहिँ लिनुपर्ने रहेछ है. ओके, साइन 45 भनेको कति हो त? 0.7071 हैन, 0.7071 त्यो भ्यालु राखौँ यहाँ. .7071 र अर्को के छ साइन 28. sin 28 को भ्यालु चाहिए है sin 28 को भ्यालु कति हो त त्यो पनि यहाँ क्याल्कुलेट गरौँ cot 28 sin or sin 28 हैन 0.4694 मैले 4 डिजिट लिए है 0.4694 हैन अब यसलाई इक्वल्स टु गर्दाखेरि कति आउँछ त फेरि पनि त्यही क्याल्कुलेटरमा हेरौँ यसलाई अलि सानो बनाऊँ है त अब मलाई बेसिक क्याल्कुलेटर भए पुग्छ है स्ट्यान्डर्ड ल हेरौँ 0.7071 divided by 0.4694 equals to ल्याएर कति आयो 1.5063 okay 1.5063 so this is your answer therefore refractive index of the glass is if you take only one digit then it will be 1.5 only but if you want to take all 4 digits then it will be 1.5063 I prefer to take up to 4 digit in science okay take up to 4 digit that is standard okay any confusion here if you have any confusion you can always ask me okay the only problem is I cannot hear you like this okay but you can call me or you can contact me with the messenger if you have any confusion okay okay I heard you say okay okay now if you have copied this let's go to next question question number 2 calculate the refractive index of if the speed of light in vacuum okay vacuum is considered as the medium 1 in this case okay V okay capital V in vacuum vacuum is considered as medium 1 in this case okay it considers that light is traveling from vacuum into water yes so it is given 3 into 10 to the power 8 meter per second yes and speed of light in water is also given means V water okay how much 2.2 into 10 to the power 8 meter per second this much information is given to you yes now what you need to find out refractive index of water okay let me not make it complicated as in before yes you can simply write mu equals to what okay if you want to write the complicated form then you can write here water do you know why we are not writing vacuum here okay because nothing is there means obviously it is vacuum you don't need to write that okay now as we know okay which formula do we have to use if the speed of light is given speed of light in two mediums are given which one number 1 number 2 or number 3 well I heard your answer yes you said number 2 isn't it okay I'm going to use number 2 had you said number 1 I would have used number 1 okay let me use it number 2 formula Ri is equals to this what is this velocity of light in medium 1 by medium 2 now tell me what is medium 1 in this particular example in this particular question it is vacuum and what is medium 2 in this particular question it is water so velocity of light in vacuum by velocity of light in water okay or Ri is equals to, once again we need to copy this, we need the fraction. Okay, now what is the value of velocity of light in medium 1? That means in vacuum it is 3 into 10 to the power 8 meter per second. Yes, and what is the value of velocity of light in medium 2? That means water. It is 2.2 into 10 to the power 8 meter per second. Okay, now here you can see that this 10 to the power 8 and 10 to the power 8 can be cancelled out, isn't it? So it ultimately gives you 3 by 2.2. Yes, so that gives you the value of, okay, 3 by 2.2, 3 divided by 2.2, 1.36. Okay, so you get the answer 1.36. Therefore refractive index of water is 1.36. This is your answer. Any confusion up here? Okay, no confusion? Okay, then if you do not have any confusion, then I am going to the next question. I am moving to the next question. Okay, the third question, see, the refractive index of water with respect to air is how much? Ri of water with respect to air. That means how is it written? Actually you do not need to write, you can simply write mu. Okay, you do not write it in detail. Anyway, if you want, and it will be like this. Air. Okay, air to water is equals to 1.33. It is given, and you know that Ri does not have any value. Okay, sorry, I said values. No, that's not valid. I meant to say unit. Refractive index does not have any unit. What is next information given by the question? Real depth. Yes, a pond is 15 meter deep means real depth of the pond is equals to 15 meter. But does it seem to be 15 meter? Definitely no, it doesn't seem to be 15 meter. We just discussed it. Yes, and that will be its apparent depth. We don't know it. See, how deep will the pond appears to be? That is what we need to find out. As we know, once again we need to use the formula of refractive index. Now which one do you have to use? See, once again let me go through formula or relation number 1, relation number 2 and relation number 3. Which one? Did you say 1? No, it's not 1. If you say 2, then it is also wrong. But I know you didn't say 1, you didn't say 2, you said 3. I know that. Okay, I was just messing up with you. Okay, number 3, real depth by apparent depth equals to refractive index. Let me use this formula. Okay, real depth, okay, or Ri is 1.33 is equals to real depth and apparent depth. You need to replace the value whichever you know. Okay, you know real depth, isn't it? Real depth is 15 meter and apparent depth you do not know. Now how to solve this type of question? You need to do cross multiply. Yes, so by cross multiplying you get apparent depth on the numerator of left side. Okay, and in on the right side what you get? Okay, this is still here, 15 meter divided by cross multiplying you get 1.33 on the denominator of the right side. Do you understand this or not? के भएको यहाँ बुझ्यो कि बुझेन हेर त यहाँ भयो के भन्दाखेरि गजब भयो के गजब भएन एकदमै सिम्पल कुरा भयो यो अपेरेन्ट डेप्थ यहाँ माथि आएर मल्टिप्लाई भयो हो र यो 1.33 तल आएर डिभाइड भयो यति एक्सचेन्ज भएको यो ओके only that much है एन्ड यसले फाइनल भ्यालु तिमीलाई कति दिन्छ त भन्दाखेरि apparent depth is equals to 15 divided by 1.3 गरी हेर 15 by 1.33 11.27 11.27 meter. You got the answer? Therefore the pond appears to be 11.27 meter deep. Right? ल यति भयो आजको न्यूमेरिकल अब तिमीले असाइनमेन्ट गर्नु पर्यो असाइनमेन्ट भनेको होमवर्क है असाइनमेन्ट गर्नु पर्यो असाइनमेन्टमा हेर त क्वेशनहरु हेर यसलाई पनि म नेक्स्ट पेजमा पठाइदिन्छु है हेर्न सजिलो हुन्छ नि ओके खै त आराइज ल असाइनमेन्ट हेर क्वेशन फर्स्ट क्वेशन माथिको तीनवटा क्वेशन त तिमीहरूले फेरि गर्नुपर्छ नै है प्लस त्यसैले यो चाहिँ के भयो त 4 नम्बर भयो नम्बर 4 मा के छ क्याल्कुलेट द भेलोसिटी अफ लाइट इन वाटर इफ इट्स रिफ्र्याक्टिभ इन्डेक्स इज 4/3 सक्छ है रिफ्र्याक्टिभ इन्डेक्स दिएको छ and next question the refractive index of a glass is 1.5 and the speed of light in vacuum is 3 into 10 power meter per second find the speed of light in the glass next question calculate the refractive index of a substance if the angle of refraction and incidence are 30 degree and 45 degree respectively सक्छु हैन र अर्को अब गिभ रिजन क्वेशन मैले अघि भर थपेँ थिएँ a pond appears to be shallower than its actual depth why यो चाहिँ न्यूमेरिकल हैन नि फेरि यो गिभ रिजन क्वेशन है ल आजलाई यति गर्नु है we will see you in our next class we'll discuss about the effects of refraction in our daily life okay until then goodbye and see you in the next class. Thank you class.